So good afternoon everyone. So in this video we are going to discuss about thermal conductivity gauges. Okay. So in the thermal conductivity gauges, the temperature of the given wire through which electric current is flowing depend on the magnitude of the current, resistivity, the rate at which heat is dissipated. The rate of heat dissipation largely depends on the conductivity of the solid medium. So we take down this Prani thermal conductivity gauges. So normally the heated filament they are given, the vacuum pressure was supplied over here. Okay, so here the principle, it will be heated the wire is placed on the gas chamber. The thermal conductivity of the gas is depends upon the gas pressure. Okay, so the transfer energy from the wire to the gas is proportional to the gas pressure. If the supply of heat energy to the filament is kept constant and pressure the gas is varied, so then the temperature of the filament will alter, and therefore the method is pressure measurement. So whenever the vacuum pressure is supplying over here, vary the vacuum pressure according to that it will be temperature. That means the passing of the heat filament towards to the filament, it will be differs. Okay, so that by increasing the value from here, the value, then we are going to know about the pressure of this particular channel. Okay, so in the simple way you can say about this Prani thermal conductivity like this. Okay, so then it will be works on the principle of some bridge circuit. So bridge circuit like this. So if we take down in this Prani gauge, okay, so the heat loss of the filament, okay, this also is a function of temperature, ambient temperature, and the compensation of the effect can be achieved by connecting two gauges in series as here shown in this figure. Okay, and also the measuring gauge first evacuated and uh, both measuring and sealed gauges uh, exposed into the environment condition. The bridge circuit is then adjusted through the resistor R2. Resistor R2 and get null condition. First, initially we are going to keep into the null condition. When the measuring gauge is exposed to test into the vacuum pressure, the deflection of the bridge from the null position will be compensated for the changes in the environmental temperature. So the Prani gauge require calibration and are not suitable for use at pressure below at 1 micrometer, and upper limit is about 1 torr. Okay. So for higher pressure, the thermal conductivity changes very little with pressure. As it must noted that the heat loss from filament is also function of the condition losses to the filament supports the radiation losses on of the surroundings. The transient response of the Prani gauge is poor. The time required to achieve thermal equilibrium may be in the several minutes at a low pressure. Okay, so this is about the Prani gauge. Simple way you can say. So actually, this is the closed chamber. Here it is the open chamber, which are the thing pressure has to be measured over here. We are going to keep. Okay, so the first initially the resistance we are going to R2 resistance we are going to keep it as a null. Okay, suppose that depends upon the pressure, it will be varies. Okay, according to the gas proportion, the conductivity of the thermal conductivity, it will be varies. Okay, so that according to that the resistance value changes. So to increasing the resistance value, okay, into this R3 level, okay, will increase over here, so that from the help of that we are going to measure the pressure value over inside the system. Okay, so like this way going to measure this Prani thermal conductivity gauges. Then come into the thermocouple vacuum gauge. So this is a thermocouple vacuum gauge. Also it works on the same principle of the Brownian gauge, but it will be differed by the measuring the filament temperature. So in this gauge, filament temperature is measured directly by means of thermocouples welded directly to them in the figure. Okay, thermocouple directly welded with the figure. So it consists of heater, filament. So this is the heater filament, and thermocouple enclosed in a glass and envelope. So normally it is closed with that one, and the filament is heated a constant current, and its temperature depends upon the amount of heat loss surroundings by conduction of and convection, by conduction and convection. At low pressure, the temperature of the filament is a function of the pressure of the surrounding gas. So thus the thermocouple provides the output of voltage which functions the temperature of the filament and consequently the pressure under the surrounding gas. The moving coil meter may be directly calibrated the read of pressure over here. Okay, so this is about the thermocouple vacuum gauges. Okay, so in simple way it can could able to tell means the vacuum pressure is supplying over here. So according to that, the heated filament, okay, it will be varies its conduction property, thermal conductivity property. So due to that, what happens, we are going to increase the with the help of the rheostat to increase the current supply, so that it can be recorded with the ammeter. So from that we are going to find out the vacuum pressure over inside the this glass tube. Okay, so this is about the thermocouple vacuum gauge. Thank you.